Okay, so when you're working on these concept builders that look something like this, I just want to point out, we may or may not do this in class, probably have it set up at least to do some of it, but I want, whether or not you're actually doing this, I at least want you to be aware of what the real life version of this would look like. And so we have some equipment here that it's this, it's a bar like this, and you can see we can actually measure angles. The angle that something is, you see that red string, if I was holding it like this, we could see whatever that number is would tell us the angle. The way we would set this up is you have a block of wood, and you have this bar here, and you also have this piece here. So the bar fits through here. There's a knob. As you move this up and down, you can tighten the knob. But then this block, and you have the end of this goes in. So when you, you put this in here, that goes through. But then this just sets on the table. So we'll move this down so you can see. This just sets on the table. And then there's a hole in the, probably, there's a hole in both sides, but you want the side that has the higher number on it. It says 60. There's a hole in that, and this goes through that hole. So you can see that bar goes through there like that. And what this allows us to do is this holds us stable, and we basically can set up an inclined plane, and then we can see the angle from what this shows right here. So whatever our angle we want it to be, we can set it up. And then you can set up a frictionless surface. We have this little cart. You can set up a frictionless surface because the cart has wheels and it'll roll on it. Or you can set up something with friction, like a little block of wood. You can set a block of wood on here, and of course right now it slides down. If you want to change the angle, there's two ways. One, you can just lift it up with your hand, and you can see the angle changing right here. And if you were doing this, you could see, well, at some point, friction stays and stays. Eventually, the force of friction isn't enough, and this thing's going to slide. You could actually calculate a lot of data with that. You could calculate the coefficient of friction once you get this angle when this thing does slide. Oh, right there. You could measure that angle and say, well, what angle does that start sliding? You also could measure, as this one shows, change that. You can measure, well, what would this force downhill be if I had no friction? And even if you had different masses, you could change the mass. So for example, you could take this cart and you could, this is a 500 gram mass, so you could take this mass, easiest way, the safest way to do this is just to use some tape. You could take the mass to the cart using more tape than that. Maybe make it stand up. Yeah, depends on the shape of the mass and how you want to end up doing it. But you could use a, by the way, if you do tape it, make sure that the tape's not binding up these wheels on here. You could use a scale to find the total mass of this. Well, what is the mass? And then that would give you this mass that you have right here. This mass you have right here. Then you could set this on here. You could calculate what is the force supposed to be parallel there. Then you could actually measure it using our forces that we can measure with. And you could do that by, of course, hanging it here. And then letting it pull. You'll see it pulls. And you could measure that force. What would the force downhill be? This is how you would set this up. We certainly will do this at some level as demonstrations or else in class. But thank you, and have fun with inclined planes and physics.